introduction. I appreciate the opportunity to be here. Been to Stalker Day many times, but my first time on this end. Lots of friends and colleagues here. Glad to be here. Part that Dale failed to mention is several weeks ago we sat down and literally over beer and we're talking about what do you want to talk about? What I know you do interesting stuff. And I said, well, that was interesting. Actually, I told him what I do every day isn't very interesting. I work with the data and sit in front of a computer every day. But some of my team has done some stuff that I think might be of interest. So we're going to talk about that a little bit. I'm kind of going to talk about two different topics. And I want to shout out to Taylor McAtee. Raise your hand, Taylor. Taylor's up here in the front. She's a PhD student currently. The first thing I'm going to talk about is some BRD treatment studies that Taylor had an opportunity to work with a couple different veterinary consulting groups and different producers across the country, actually across North America, did several studies to look at, what might be the best BRD treatment for certain cattle populations at certain times. And so I'm going to summarize some of those data for you here today. And then secondly, I'm going to spend a little bit of time on some work that Dr. Lucas Horton has done. And Lucas is up here. Raise your hand. I won't make you stand up. Lucas finished up his PhD last fall and has done a lot of work on health and performance and how that interacts with economic decisions. And one of the things he's worked on recently is gets to what Dale was talking about is, what could you afford to pay to get more calves across the finish line? And so he's done some rather complicated modeling, but also boiled it down into a decision tool that's on Ag Manager that's available. So wanted to run through that a little bit and see, and at least introduce you to it. So if you might find it useful, you can go there and use that tool. Speaking of tools and making decisions, I think that's really the crux of what I do and we do as researchers is you guys, the producers and veterinarians, are making these decisions. And so what I'm going to try to do here is just, provide more information so you can make more informed decisions. And that's kind of what we see as our role as researchers. So let's jump into the BRD thing. You guys all know more calves get sick and die from BRD than anything else. That's a challenge we face all the time. Probably one of our most effective tools, if you want to lump it into a big bucket, is antimicrobials or antibiotics. We can kind of, if we want to make buckets, we can kind of talk about that in two spaces. Using antimicrobials on the front end to the whole group for metaphylaxis. And then if they get sick, what do we treat them with? And so that's mostly what I'm going to talk about. But what we treat them with, there's a lot of debate, science around, does it depend on whether they receive metaphylaxis or not, and what they received, what product was used for metaphylaxis. So there's quite a few studies out there, but if you think of all the combinations of different products and different cattle types in our industry, there's a bunch of questions and there's a diversity in terms of answers, and we don't always get the same response. I did want to point out, obviously, these products, and we're talking about antimicrobials, are prescription products, and so not only is it legally important to have your veterinarian around in these decisions, I think if you see some of the data I'm going to present, you'll recognize there's also an opportunity maybe for them to help wade through some of the data that's out there, because there is quite a bit of variability in what we see, depending on cattle type and depending on what's used for treatment and so on. So I'm going to talk about 3 different trials that Taylor's in the process of getting published. These are all what we call randomized clinical trials, and they're all a little bit different, and I'll point out some of the differences. I don't have time to get into a whole lot of detail, but what's similar with all of them is we get the cattle in, we focus on a certain study population, right? Do we want to look at treatment for high risk 400-pound calves, or do we want to look at, 800-pound yearlings and so on? Typically with these trials, and the three that I'm going to talk about were all done in commercial production facilities, not done in a university setting, but done in collaboration with producers. And so typically, as our last speaker talked about, we tend to use their SOPs for processing. And then you'll see I'm going to talk about two studies where we used metaphylaxis and another study where we didn't use metaphylaxis. But all of the calves are treated the same up until when some of them get sick, when we're talking about these clinical trials. When they get sick, that's when it becomes the experimental process where we randomize each sick cattle to one of the treatments that we've defined as part of our study, right? Interesting time, I'm not going to go through all the details in terms of dose and so on, but all the products were used per label and so on. So keep this sort of process in mind, because that's what we do in all of these trials. The first one was actually done quite a few years ago, and it motivated the second one. So it's almost more of a background story than something that we were real intimately involved with. But the first study, all the calves received Draxxin for metaphylaxis, and then when they got sick, they were randomized to either receive Resfor Gold or Draxxin KP. And so I'll get into this a little bit more later, but the question here really was, as many of you know, Draxxin, or there are other tulathromycin products out there now. Draxxin was the pioneer product from Zoetis. If you use tulathromycin type product for metaphylaxis, and then they get sick, could you use something very similar, which is Draxxin KP in this case, or a different drug class, which is Resfor Gold? And again, I'll talk about that a little bit. But, so this one's pretty straightforward. They all received metaphylaxis, and there were two treatment groups. These were 400-pound auction market commingled calves in Texas. There were 520 of them, 21 of them that got sick. So those are our BRD cases that were then allocated to the two treatments. And again, they all received metaphylaxis prior to that. I'm going to, for the interest of time, just tell you, we didn't see any significant differences between these two treatment products in this population. And one of the things, and so to set this table up a little bit, you have the columns for Draxxin KP and Resfor Gold, and you see about 60% of them had to be retreated. So they were given metaphylaxis, they were treated with one of these products, and then 60% of them had to be treated again. And that wasn't different between the two treatment groups. Of those BRD cases, about 2% of them died from BRD based on necropsy, and about 3% of them died from anything, right? So that's our BRD case fatality and overall case fatality. So a couple take-homes here is, at least in this study population, and we didn't see any significant differences between using Draxxin KP or Resfor Gold to treat these calves following metaphylaxis. I'll get to this, I'll illustrate this a little bit more, but one of the reasons that the second study was done is these fatality numbers are actually way lower than what was expected in these calves. I mean, these were, again, four weights, high stress, commingled. The producer and the veterinarian consultant group involved with this study, this is much less than what they expected in terms of death loss. So it turned out to be a little bit different of a study population than what was intended. But again, no differences between those treatments, and we looked at lots of other things. I'm just showing you a few outcomes here. So this sort of motivated the second study, and so it's fairly similar in the sense of the calves received Draxxin metaphylaxis. The only difference here in terms of study design is now we got three treatment groups. We got Draxxin, Resfor, and now the third one is Zuprevo added here. So again, similar setup as the other one. Again, stale-born calves, commingled type high-risk calves, and this study was actually done in Canada, Saskatchewan. These are what this consultant group and producer called ultra high-risk calves, and this gets at to what I was explaining earlier. You know, what we expected going into this study population was after receiving Draxxin, still expected 10 to 20% of them to get sick. Expected up to 3% of them to die. And of those that were cases, the case fatality that I talked about a little bit earlier, the expectation was that would be between 10 and 15%. So quite a bit higher than what we observed in the previous study, right? And when I say expectation, this isn't just a guess. This is based on historical data from knowing the source and the type of cattle that they've fed over time. So again, similar setup. All the calves are brought in, processed, given Draxxin, identified as sick, and then randomized to 3 treatment groups: Draxxin, KP, Resflor, and Zuprevo. I failed to mention on the first study, for both of those 2 studies, there was a 5-day PMI, or 5 days after giving Draxxin, they weren't eligible to be treated. So that was what happened in this study and the previous study. So I'm adding here the drug names, the compound names that are in these treatment groups, because to give you a little bit of sense of some of the motivation here is, again, if we give Draxxin, which is tulathromycin, it's in the drug class called a macrolide. Some of the questions that science and veterinarians and others have talked about is, if you give that on the front end for metaphylaxis and then they get sick, you need to use a different drug, a similar drug, a whole different class of drugs. So Draxxin is a tulathromycin. Draxxin KP is tulathromycin with the addition of an anti-inflammatory. So same antimicrobial though. Resflor is fluorophenocal with flunixin in it, which is also an anti-inflammatory, or you probably know it better as Banamine. Different drug class though. And Zuprevo is also a macrolide, so it's in the same drug class as tulathromycin. Others that are macrolides, like Micotel, you may recognize. So there's a number of them that are macrolides. So we've got Draxxin up front, and then either another tulathromycin, another macrolide, or in Resflor, a different class of antimicrobials. So that's kind of the background and motivation there for why these were the drugs that were evaluated in this study. This just shows you a little bit more about those calves. There's columns here for Draxxin, KP, Resflor, and Zuprevo. Zuprevo's on the right. You see we had about 260 animals in each group, and what their body weight and when they were enrolled or when they were pulled and treated on average, and the rectal temperature on average. The main thing with those is that you see they're really similar within groups. That's on purpose. That's what the randomization does for us. So then we apply those treatments and see what happens, right? See what sort of outcomes we get. So I'm going to kind of walk through, what happened to those calves. So we had, I said, 260, a little bit more in some groups. Draxxin KP is the top one. That's kind of bluish gray. Resflor is the middle one, and Zuprevo is the one on the bottom there. Okay, so this first set of data tells us how many had to be treated again after those treatments, right? And it's roughly 32% in all of them, and this was not significantly different, right? It was pretty similar in terms of how many had to be treated twice. Also pretty similar on how many had to be treated 3 times. A little bit of variability in those numbers, but the statistics tell us that those aren't significantly different. And the number treated 4 times, which was deemed a chronic or rare in this study, again, there looks to be a little bit of variability, but pretty small numbers and not statistically different. The thing that was different was the dead pile. This shows the raw numbers. There were 52 in the Draxon KP group, 32 in the Resfor group, and 50 in the Zuprevo group. Okay? And so to break that down or show that the statistical results, I've got two rows here. One's overall mortality, so died from any cause, and the second row is BRD mortality, so died and were determined on necropsy to have BRD. And if you see those little subscripts, those little letters, that just tells you which groups are different from each other. So the Resfor group were different from the Zuprevo and the Draxon KP group, but the latter two weren't different from each other. So, take home, and if you want to just look at the BRD mortality, the bottom row for a second, you can see that there were twice as many that died in the Zuprevo and the Draxon KP group than died in the Resfor group. Right? So in that study, ultra high risk, 6 weeks following metaphylaxis with Draxon. I didn't dwell on the morbidity side, but we really didn't see any evidence for differences in any of the morbidity outcomes. But as I just said, the mortality was significantly different, and Resfor was decreased compared to the other two. So a third study we just wrapped up, and just recently with a partner here in Kansas, and these were a little bit different. This is a little bit different. These were medium risk calves. They didn't receive metaphylaxis, and you see the treatment groups are a little bit different. So they didn't receive metaphylaxis. The expectation in this group of cattle without metaphylaxis was, on average, 12% of them would get sick, a lot average that is, and mortality, BRD mortality would be less than 2%. So not expected to see a lot of disease, and that's why the metaphylaxis wasn't part of the protocol for this operation with this type of animal. But we still have the question of then, what do we treat them with when they do get sick? Because some of them do get sick. Although I'll tell you, for those of us that do BRD research, one of the good ways to not see as much BRD is to try to do research on it. Then all of a sudden you can't find it. But, and that was a bit of a challenge in this study. It took us a while to enroll our cases, so that's a sidebar issue. But so similar study design flow, except no metaphylaxis here, right? We got the calves in, processed according to protocol. When they got sick, they were randomized to one of the 3 treatments. And these 3 treatments are all macrolized. So there's calathromycin, Aravin, which is Merck's calathromycin, Draxon KP, which is Zoetis' calathromycin, again, plus ketoprofen, the anti-inflammatory, and Zuprevo, which is also a Merck product, and also a macrolide, but a different macrolide. It's not calathromycin. So those are the 3 treatments that were evaluated in this study. And again, there were about 230 in each group. These medium risk cattle were a little heavier. You see about 740 pounds, 750 pounds on average. When they were treated, they were about 15 days on feed, and the rectal temperatures were about the same. And that's in part because of the protocol of, they had to be so high in order to be enrolled in the study. Okay. Again, I'm just going to walk through the numbers. The ones that we started with are on the right. How many were treated twice? The Aravin on top, then the Draxon KP, and then the Zuprevo. Those numbers are all really, really similar, not significantly different. Less than 30% had to be treated, have a follow-up treatment after these treatments that we employed. Very similar numbers in terms of treated 3 times, pretty similar numbers in terms of chronics, but there weren't a whole lot of them. And the dead pile, there's a little bit of variability there, but the statistics would tell us that these aren't even close to significantly different. So big trial, took us 2 years to enroll all these calves, and no difference between those 3 products based on the study population. So again, to summarize a little bit, these 7-weight medium risk calves without arrival metaphylaxis, we didn't find any difference in any of the health outcomes in terms of morbidity or mortality between Caprivo, Aravin, or Draxxin KP for that first line treatment. So just to summarize real quick, in the 4 weights, we didn't see any difference. That study in Texas, the mortality was a lot lower than what was expected. And then the 6 weights that was done in Saskatchewan, where the mortality was higher or more what we expected, we did see a difference in mortality, but not morbidity. And ResPro was different from the Draxxin KP and the Caprivo group. And then in the last study that we just wrapped up in Kansas, there's no difference between those 3 drugs and those medium risk without metaphylaxis. So no one clear winner based on any one study, but we see a lot of variability between these different studies and the different types of cattle populations. It kind of reinforces what I said at the beginning, is that, we know that we do see, not just based on these 3 studies, but also other studies that have been done, that, depending on the type of cattle you're feeding, when you're feeding them, where you're feeding them, what their disease burden is, and the risk category is, there is no one clear right answer for all those different situations. So it's important to consider all of those factors with the consultation of your veterinarian. And so with that, I'm going to shift gears a little bit and then get to the second piece of my presentation, which was the question. Really, the driver of this question was, we've often over the years looked at different interventions to improve health and how cost effective they are. And there's been lots of studies and a lot of work probably that you've done too to look at, what does it pencil out to do A, B, and C. But with the price of calves the way they are, maybe the question or the answer to those questions has changed a little bit, right? Death loss is costly. It's always been costly, but I was thinking about today. Now a calf costs about 5 times what my first car cost, right? Not that I had a good car in my first car, but calves are expensive. Death loss hits the pocketbook pretty hard, right? And there's a number of things that we can look at that can potentially affect death loss. So I've talked about antimicrobials on the first part of the presentation. As we talk about this part, think more broadly. It could be antimicrobials, it could be metaphylaxis, but it could be any intervention that might have a positive impact on health or mortality. I'm going to call those interventions. Our previous speaker used the term tools, kind of the same thing, right? But there are things that we might employ to reduce mortality. Do they pay? Do they work in your system? And particularly when you talk about the economic decision of whether they pay for themselves or not, there's several factors that you need to consider. And again, I mentioned Lucas has done some pretty complex models looking at market conditions and so on. But one of the things that he just recently put on the Ag Manager website was a decision tool that we can walk through. So what are the factors that you need to consider? There's probably a long list, but relative to the intervention or the product, if you will, the thing that you might do, it doesn't have to be a product, it could be a husbandry type situation. What does it cost to do that? In this case, we're kind of working backwards because we're going to say, what's the break even? So anything below that pays, and anything above that, we might be paying too much. But the other part is, how well does it work? What is the expected reduction in mortality? Does it cut it in half? Does it cut it in a third? And so on, right? So those are kind of a couple of the factors. Again, just like we talked about with the antimicrobial data, the cattle population and what you expect in terms of performance and mortality risk play a big part of that, right? Because it's going to vary depending on what mortality you expect. And then, of course, the economic price of, the price of cattle, price of feed, all the other parts that go into operational business decisions. So sort of the take home from his bigger model is it depends. It depends what some things might pay for themselves in certain situations and not others, right? And a simple thing of thinking about that is, you cut death loss in half. Okay, well, half of what, right? If you got 1 out of 1,000 dying and versus you're expecting, a 5 or 10% mortality, cutting it in half is a different math, right? So depending on the market conditions and the type of cattle, the decision or the break even, I should say, really will change. And I know Dr. Tonser talked about Ag Manager this morning, that website. We just recently put that up there. So if you go there and you open it up, it looks like this. And I know you in the back of the room are going to say, I can't see any of that. Well, I can't see either, and I'm up front. So I'm going to break it down and just show you what it does and how Lucas built it, and then, give you an idea how you use it. So there's a part where you put in, what type of cattle are we talking about? And he built this one more as a feedlot closeout, but you could do it more as a backgrounder if you wanted to. So, but you put in, what you expect in terms of arrival weight and average daily gain and so on. In terms of mortality, you have to, that's the middle. I'm scared to push the button after the last speaker. But the middle line is, what do you expect the decrease in mortality to be? You cut it in half, you cut it by 25%. In this case, we're saying we expect mortality in these 7-weight calves to be 2%. That's that yellow box on the bottom there. And we expect this intervention to reduce it by 25%. So if we use the intervention, instead of 2% death loss, we're going to have 1.5% death loss, right? That's 25% less. So that calculates that for you once you determine, how well does this intervention work and how much is it going to change mortality. And then you have the aspects of, of price, feeder price, feed price. And this is all based on a live basis. Again, keep things simple, but, what do you expect to be paid at the end? That comes into at this point. And then the results are set up. So if you can see, there's kind of 2 columns, current and intervention. So current meaning if you keep doing what you're doing and expect what you've been expecting, versus the intervention, you use the intervention, and how does that change? And you see some of the things don't change. What you paid for them doesn't change, but some of the revenue part changes. The punchline is actually, the bottom line is up top, right? That's the net return difference on a per head basis. So the break-even cost for the intervention on a per head basis, and the number there is $14.94. Meaning, if whatever tool you're thinking about employing, whether that's a husbandry decision, antimicrobial, whatever it is, if it costs less than that, on average, it's going to pay for itself. And if it costs more than that, then you may either choose not to use it, or there may be other reasons that you need to use it besides just the economic consideration. So that's the reason this was built, is to get out this number. What is the break even for these different scenarios? And what's really useful and interesting is when you start running through different scenarios, because again, it depends on what paid, it depends on how well the intervention works, it depends on what you expect in terms of mortality. And so here's an example. Again, I've used or I should say, Lucas has used, because he provided this for me, the 7-weight data that I showed before in this scenario. And then we've got two different economic scenarios, and he's pulled fairly current numbers and then numbers from 4 years ago. And so you got corn price and feed and cattle prices there, kind of to compare and contrast how much things have changed a little bit. And then the other scenario, part of the scenario I wanted to show was, okay, if you have this intervention that is 25% effective or reduces mortality by 25%, what is the break even? It depends on what you expect mortality to be in these type of cattle that you're asking the question about. So we've done scenarios with 0.5%, 2%, and 5% expected mortality. And so here are the results. For a minute, ignore the historical stuff, the August 21 on the right, on the bottom right, and just look at the current situation with the numbers that we've used here. If you expect a fairly low mortality, less, 0.5%, then reducing that by 25%, the break even for that intervention is only $3.70, right? But if you jump down to the bottom row and you say, well, if this type of cattle we expect based on previous feeding this type of cattle that there's going to be about 5% mortality, then you could pay up to $37 for something to reduce that by 25%. So again, it shows how important that is, what your expected mortality is to what you'd be willing to pay for an intervention to reduce mortality. And then the other thing it shows is if you compare to 4 years ago, it kind of gets at what I was saying earlier, and even Dr. Blasey said that what cattle are worse today, we can roughly pay twice as much to reduce mortality than we could have 4 years ago. I mean, that's a rough sort of conclusion, but you can see those numbers are about half or double what they would have been 4 years ago. Right? So again, this calculator is available at Ag Manager. We thank Dr. Tonzer and Dr. Schroeder, who economists who kind of kept us out of the ditch, make sure Lucas did the math right. And some of the things that I think are important to point out is kind of the take home is, what you can pay depends, right? It depends on the price of cattle. It depends on how well the intervention works and so on. And there's a lot of factors that come into that, and this may help. Important to know that, we use live prices. These are averages. The other important thing to recognize is that this is based entirely on what would mortality change. So if you have an intervention that reduces mortality, but also reduces morbidity and improves average daily gain, there's going to be more benefit to that than what's included in this calculator. So make sure to keep that in mind. Okay? Well, I'm standing between you and break, so I'll be happy to take any questions. And that's the website, the Ag Manager website. If you want to jot that down, or you can email me and I can direct you there. Thank you. Yes, sir. Yeah. Yeah. So the question is before we evaluate the effectiveness of this drug, what happened to the calves before? And so the short answer is it was different in different studies because they sourced the calves from different places. And the processing, vaccination, and dewormer and all that was the same at the facility. And so the important, Taylor and I can share you the details of exactly what they got, but important for the study is it was similar with all of them, right? And so by randomizing across that they when we applied the treatments, they had the same sort of background, if you will, across the treatment groups. But definitely, you know, those, particularly what happened before they got to the trial site, especially with those commingled auction markets, we don't know. I mean, they're that kind of cattle, right?
The moratorium is not more or less marks that those that regular practitioners have COVID 5, maybe 3 days, 7 to 5. How much of the impact is it possible on that have?
It can have an impact. There's some consulting vets in the room, and I think the one thing they'd agree on is that they disagree about that. And it's fair to disagree because I think certain situations there's other considerations. I think some of the companies have done more than others in terms of doing post metaphylaxis interval studies at 3, 5, 9, 7, etc., and seeing where does it look like the sweet spot. And so there is some good published data on some of them, particularly from some of the pioneer products that's out there.
They have this data on the calendar, but they're seeing gas that look like they exist now.
Right. Yeah, that's hard, and that's actually hard when you're doing this kind of research too, because you're saying no, you got to wait till day 5, right? And they don't want to. They look like they need some help. Yeah, I don't know that I have a good answer to that. I guess thinking more holistically, I wouldn't count on us as veterinarians and producers to have a lot more tools in the future in terms of new antimicrobials. There's some changes and there's some generics. I mentioned there's a lot more products. For years there was one for filatromyces and Draxxin, right? And now, since it's been come off patent, there's several companies that have this filatromycin, and so that's what I was referring to. Is there's a lot more products, but in terms of the compounds, I'm trying to think, but I don't know of anything that's coming out new. I failed to mention, I do want to mention both as acknowledgement and full disclosure that Merck supported those 3 clinical trials. And I also wanted to mention that ILS, many of you know ILS, the Kansas company, also participated in some of the studies, and both of those 2 companies really appreciate that they help support the grad program for Taylor and Lucas, and have been a big supporter of helping us educate our students. Sorry. Okay, help me out. It wasn't the same in all of them, I can tell you that, but it was close. Yeah. So to repeat that the rectal temperature varied a little bit between the 2 studies, or the 3 studies. In all of the studies, they had to be identified as sick by by the cowboys pulling in trees, brought up and determined they didn't have something other than BRD. It didn't have to be trees with something other than BRD. So if they were treated for foot rot or something with an antimicrobial, at least they weren't